Straight copper wire has fixed voltage applied across its length. Which of the following changes would increase the power displayed by this wire? Hint to the relation between P, R, and V. A. Decreasing the length of the wire I, decreasing the cross-sectional area of the wire A, increasing the temperature of the wire T, changing the material of the wire to metal of greater resistivity P. To determine which the change, which increase of the power displayed by the wire, let us consider the relation between P, resistance, and voltage, which given the formula P equals V square of R. Decreasing the length of the wire I. According to the formula, as the length I decreasing, the resistance R decreases. Since power P is inversely proportional to resistance R, decreasing resistance increases power. So decreasing the length of the wire would increase the power dissipated. Decreasing the cross-sectional area of the wire A. If the cross-sectional area A decreases, the resistance R increases as per the formula, increasing resistance, decreasing power. Therefore, decreasing cross-sectional area of the wire would increase power dissipated. Increase the temperature of the wire T. Increasing the temperature T of the wire increase resistance R, which decreases the power dissipated. So increasing temperature of the wire would decrease the power dissipated. Changing the material of the wire to metal of greater resistivity P. If the resistivity P of the material increase, the resistance R the wire increase. As per the formula, increasing a resistance decrease power. Therefore, changing the material of the wire to a metal greater resistivity would decrease power dissipated. Based on the analysis above, the correct answer is A, decreasing the length of the wire I. Which of the following phenomena describe the following statement? Traveling glass rod with the silk clothing. Triboelectricity, polarization, electrostatic shielding, charging by induction. The phenomenon described as the rubbing glass rod with the silk clothing is the best represented by triboelectricity. This phenomenon involves the generation of static electricity through friction when the two materials are rubbed together and become electrical charge. Rubbing glass rod with the silk is a classic example of the triboelectric charging, where electrons are transferred between the materials, resulting in one material becoming positively charged and the other negatively charged. Consider 3 points A, B, C in the uniform electric field shown in the figure. Which of the following is correct regarding the electric potential at these points? A, VA greater than VB greater than VC. VA equal VA less than VC. VA equal VB equal VC. VA equal VB greater than VC. Solution. To analyze the electric potential at point A, B, and C in uniform electric field, let's consider the following. 1. Point A. It is located closest the positive plate, assuming the electric field points from positive to negative. So it has the highest electric potential among the 3 points. 2. Point C. It is located first from the positive plate, so it has the lowest electric potential among the 3 points. 3. Point B. It lies between point A and C, since the electric potential decreases with the distance from the positive plate. Point B will have an electric potential between that of point A and C. So the correct answer option is A, VA greater than VB greater than VC. A conducting wire double in both length and diameter. Its resistivity will be remain the same. B increased by a factor of 2. C reduced by a factor of 2. D reduced by a factor of 4. To determine how the resistivity changes when the conducting wire double in both length and diameter, let's first understand the factor affecting resistivity. The resistivity ρ of material is defined by the formula ρ equal Ra over L, where R is the resistance of the wire, A is the cross-section area of the wire, L is the length of the wire. From the formula, we can see that the resistivity is directly proportional to the resistance R, and the length of the wire L, and inverse proportional to the cross-section area A. When wire is double in both length and diameter, the length L is double. The cross-section area A increasing by factor of 2 raised to power 4 equal 4. Raised to power 2 equal 4 because area is proportional to square the diameter. Since resistivity is directly proportional to the length and inverse proportional of the cross-section area, when the poles are double, their effects cancel out, so the resistivity remains the same. Therefore, the correct answer is A, remain the same. Uniform electric field of 35 inside C points to the north. What force will be particle of minus 65 in C experience? A, 2.275 multiplied by 10 raised to power minus 6 in north. P, 7.275 multiplied by 10 raised to power minus 6 in south. C, 2.27 multiplied by 10 raised to power minus 6 in south. D, 7.275 multiplied by 10 raised to power minus in north. To find the force experienced by the charged particle in electric field, you can use the formula F equal Q multiplied by E, where F is the force experienced by the particle, Q is the charge of the particle, E is the electric field strength. Given E equal 35 N slash C point to north, Q equal minus 65 N, C equal minus 65 multiplied by 10 raised to power minus 6 C. Negative charge indicates is possible to the direction of the field. Now plug in the value into the formula. F equal minus 65 multiplied by 10 raised to power minus 9 C multiplied by 35 N psi C. Force equal minus 2.275 multiplied by 10 raised to power minus 6N. The negative sign indicates that the force in the opposite direction of the electric field. Since the electric field point to the north, the force experienced by particle will be southward. So the correct answer is C, 2.275 multiplied by 10 raised to power minus 6 in south. What is the cost of operating 110 volt and 10 ohms hair dryer for 30 minutes if the cost of the electric energy is 2 per kilowatt hours? A, 1.21, B, 0.605, C, 11, D, 1210. To calculate the cost of operating the hair dryer of 30 minutes, we need to find the power consumed by the hair dryer first. The power by the hair dryer can be calculated using the formula P equal V square of R, where P power of in watts, V voltage in volts, R resistance in ohms. Given V equal 110 volts, R equal 10 ohms, substituting the value into the formula, P equal 1210 watts. Now we need to convert the power from watts to kilowatts because the cost electrical energy is given in SAR per kilowatt hours. Power in kilowatts equal 1210 watts over 1000 equal 1.221 kilowatts. Next, we calculate energy consumed kilowatt hours during 30 minutes. Energy equal power multiplied by time, given time equal 30 minutes equal 0.5 hour after dividing by 60. Energy equal 1.21 kilowatts multiplied by 0.5 equal 0.605 kilowatt hours. Finally, we calculate the cost equal energy multiplied by cost per kWh, given cost per kWh equal to 2 SAR kilowatt. Cost equal 0.605 kilowatt hours multiplied by 2 equal 1.21 SAR. So the correct answer is A, 1.2 SAR. The figure to the right demonstrates what is shown as Faraday cage, where this room is created with the metal foil from the outside. As external electric charge strikes in the cage, A, the cage will shield its interior from the effect of the electric field. B, the electric field will reach the interior of the cage. C, the outer edge of the cage will have the highest charge density. D, both A and B are correct. Solution. The correct answer is D, both A and C are correct. Speed of a free electron accelerated from rest through potential difference of 100 voltage. Hint, charge and mass of electron are given in the table at the end of the exam. A 4.19 multiplied by 106 meter per second. B 17.56 multiplied by 1012 meter per second. C 5.93 multiplied by 10 raised to power 6 meter per second. D 35 multiplied by 1012 meter per second. To calculate the final speed of a free electron accelerated through potential difference of 100 volt, we can use the formula for the kinetic energy gained by the electron. Kinetic energy equal half mv square, where m is the mass of the electron, v is the final speed of the electron. The kinetic energy gained by the electron is equal to the work done on it by the electric field. The work then is given by the product of the charge of the electron and the potential difference it had been accelerated through work done equal QV, where Q is the charge of the electron, V is the potential difference. The charge of the electron Q is minus 1.6 multiplied by 10 raised to power 19 coulombs, and the mass of the electron M is 9.11 multiplied by 10 raised to power minus 31 kilograms. Given V equal 100 volts, we calculate the work done on the electron. Work done equal 1 minus 1.6 multiplied by 10 raised to power minus 19 coulomb multiplied by 100 volt. Work done equal minus 1.6 multiplied by 10 raised to power minus 17 joule. Now, since the work done equal the kinetic energy gained by the electron, kinetic energy equal minus 1.6 multiplied by 10 raised to power minus 17 joule. We can set this equal to the formula for the kinetic energy, half mv square equal minus 1.6 multiplied by 10 raised to power minus 17 joule. We know m mass equal 9.10. 9.11 multiplied by 10 raised to power minus 31 kilograms, solving for V. V square equal minus 2 multiplied by minus 1.6 multiplied 10 multiplied by 10 raised to power minus 15 over 9.11 multiplied by 10 raised to power minus 31. V square equal 3.2 multiplied by 10 raised to power minus 17 over 9.11 multiplied by 10 raised to power minus 31. V square equal 3.51 multiplied by 10 raised to power 13 meter per square second per square. V equal raised to power, V equal the root of 3.51 multiplied by 10 raised to power 13 meter per second. V equal 5.93 multiplied by 10 raised to power minus 6 meter per second. Therefore, the correct answer is option C, 5.93 multiplied by 10 raised to power minus 6 meter per second. 3-point charts are placed on the y-axis as shown in the figure below. Determine the magnitude and direction of the net electrostatic force on the charge Q1. B. What is the net electric potential energy U of the charge Q1? To solve this problem, we will first calculate the electrostatic force exerted on Q1 due to each of the other charge Q1 and Q3. And then we will sum up these forces to find the net force. After finding the net force, we will calculate the electric potential energy of Q1, given Q1 and Q2 and Q3. The electrostatic force between 2-point charge is given by Coulomb's law. F equal K Q1 Q2 of R squared, where Q is Coulomb constant. Q1 and Q2 are the magnitude of the 2-point charge. R is the distance between the charge A. To find the net force Q1, let's calculate the force. Calculate the force due Q2 and Q3 separately and then sum them up. 1. Force due Q2 F equal K Q1 Q2 over R square. F12 equal 8.9875 multiplied by 10 raised to power 9, and F12 equal 2. Force due to Q3. F13 equal K Q1 Q3 over R square 13, and go on to see the solution. Now to find net force on Q1. F net equal F12 plus F13 equal 573.44 Newton minus 367.39 Newton. F net equal 206.05 in direction negative along the y-axis. B. The electric potential energy of Q1. The electrical potential energy of Q1 due to the other charge is given by U equal 1 over 4 by epsilon Q1 Q2 over R12 plus 1 over 4 pi epsilon Q1 Q3 over R13, and go on till you see U equal 5.773 multiplied by 10 raised to power minus 7 joule. So the magnitude of net electric force on Q1 is 206.05 Newton directed along the negative y-axis. The net electric potential energy U of the charge Q1 is equal 7.73 multiplied by 10 raised to power minus 7 joule. For the electric system shown in the figure, answer the following question. Given Q1 and Q2 and Q3, calculate the magnitude and direction of the net electric field at the origin. B. Calculate the electric potential V at the point 0 minus 4 meter. To solve problem, let's first determine the contribution each charge to the electric field and electric potential at the given point, given Q1, Q2, and Q3. A. To find the net electric field at the origin, we calculate the electric field due each charge and then sum them up. 1. Electric field to Q1 equal E1 equal K Q1 over R square, where K is Coulomb constant and R1 is the distance from Q1 to the original. R1 equal square root of 0.05 square equal 0.05 and E1 equal the electric field Q1 is directed towards origin along the negative y-axis. Electric field due to Q2 E1 K Q2 over R squared, where R2 is the distance from Q to the origin, and R2 equal E2 equal the electric field Q2 is directed toward the origin along the negative x-axis. Electric field due to Q3, where R3 is the distance from Q3 to original. R3 equal E3 equal and the electric field from Q3 is directed toward the origin along negative x-axis. The net electric field, the origin, is vector sum of these individual electric fields. Since the electric field Q1, Q2, and Q3 have equal magnitude and opposite direction, they cancel each other out. So the net electric field magnitude at the origin, the magnitude of electric field due Q1 E net equal E1 equal 1.7979 multiplied by 10 raised to power 6 NC. B. To calculate the net electric potential at the point O minus 4 meter, we use the formula electric potential due to the point charge. V equal KQ over R, where R the distance from the charge to the point. Electric potential due Q1, V1 equal electric potential due Q2, V2 equal minus 2.243 multiplied by 10 raised to power 5. Electric potential due Q3 equal V3 equal the net electric potential point 0 minus 4 is the sum of the potential each charge. V net equal V1 plus V2 plus V3 equal 4.486 multiplied by 10 raised to power 5 minus 2.243 multiplied by 10 raised to power 5 plus 4.486 multiplied by 10 raised to power 5 equals 6.729 multiplied by 10 raised to power 5 V volt.